Hello, my name is Alex Charler and my topic for Eng 105 is resistance. Resistance is the opposing force that charge encounters when a potential difference pushes electrons through a circuit. The electrons collide with other electrons and atoms, converting their electrical energy into heat energy. This is essentially what resistance is. The resistance of a material is determined by the material's length, the material type, the material's cross-sectional area, and its temperature. There are various types of resistive materials, such as semiconductors, insulators, conductors, and superconductors. The resistance of a material can be calculated using the following equation: R equals rho multiplied by L over A, where R is the resistance of the material in ohms, L is the length of the material, rho is the resistivity of the material, which is in the units of the ohm meter, and A, which is the cross-sectional area of the conductor. The resistance of a material can further be calculated dependent on temperature from the following equation: R equals R reference, brackets, 1 plus A, open another brackets, T minus T ref, close brackets, where R is again the resistance in ohms, the reference resistance is the resistance of the material, usually at 20 degrees Celsius, alpha equals the temperature coefficient of the resistance for the conductive material, T, which is the temperature of the conductor currently, and T reference being the reference temperature that alpha, or the temperature coefficient, is specified at. A positive temperature coefficient refers to a conductor, whereas an increase in temperature will lead to an increase in resistance, whilst a negative temperature coefficient refers to a semiconductor or an insulator, where an increase in temperature leads to a decrease in resistance. I'll now demonstrate different types of conductive materials and their associated resistances with the use of a multimeter. I'll first demonstrate the resistance through a copper wire, being 0.1 ohms, indicating a very low resistance. Next, I'll test the resistance of the insulating material outside of the wire. OL on the multimeter indicates open loop, indicating that the scale of this resistance is too high for the multimeter to test on the ohm scale. Next, the first resistor with a resistance of 10 ohms. Now the second resistor of the same size with a resistance of 1 mega ohm. From these examples, you can clearly see the varying resistances of different materials.